is according to the head at the inlet of turbine. So classification wise there are three types. High head turbine, the head is from 150 meters to 200 meters or even more. Example is Pelton wheel turbine. Second is medium head turbine, which has head 30 meters to 150 meters. So it has moderate quantity of water, for example Francis turbine. And third one is low head turbine, which has the head less than 30 meters. This has large quantity of water, for example Kaplan turbine. Fourth is according to the specific speed of the turbine. So what is specific speed? The definition is as it is: the speed of the geometrically similar turbine that would develop unit power when working under a unit head. So unit head is nothing but 1 meter. So whenever a geometrically similar turbine is there, so the specific speed depends on unit power as well as unit head. So according to the specific speed, turbines are classified as low specific speed turbine. So the speed is less than 50. So about 10 to 35 for single jet and up to 50 for double jet. So depending on number of jets, the speed may vary, but it is less than 50. For example, Pelton wheel turbine. Next is medium specific turbine. In this case, the specific speed varies from 50 to 250. For example, Francis turbine. And third one is high specific speed turbine. The speed is more than 250. For example, Kaplan turbine. So in this case, you can see a multi-jet turbine. Here are the jets. So nozzle coming out of attached to the end of the penstock. Number of nozzles are there, or you can see jets going tangentially. This is tangential turbine. These are the buckets you can see around the periphery. This will be the shaft of the turbine. So as the jet coming out of the nozzle which strikes the bucket, as you can see the direction, in this direction, this turbine, that is the runner, will start rotating, the shaft will start rotating, and so on. So if you closely see that what is the difference between impulse turbine and reaction turbine. So the impulse turbine, as we have seen, the entire energy available is only kinetic energy, which is at the inlet of the turbine. Reaction turbine has both kinetic as well as pressure energy. In impulse turbine, work is done only by changing kinetic energy, while in reaction turbine, partially it is done by changing velocity and partially by changing pressure head. Third one, in impulse turbine, flow regulation is possible without loss. In reaction, it is not possible. Unit is installed above the tail race in impulse turbine. In reaction turbine, it is submerged in water below the tail race. We are going to study this in next unit, next topic. Next, impulse turbines. The casing has no hydraulic function as such, as we are going to see in Pelton wheel turbine. It is only to safeguard the high rotating turbine from the other people around. Also, casing in reaction turbine has some kind of hydraulic function that will be seen in during Francis as well as Kaplan turbine. Impulse turbine, it is not essential that the wheel should run full, because the casing also should not run full, and air is always there present in that particular turbine casing. But in reaction turbine, there should not be any air present. The casing should run fully by the water. So for example, impulse turbine is Pelton wheel turbine, while reaction turbine is Francis turbine and Kaplan turbine.